to reduce emissions using high efficiency fixed vane scrubbers. I express my gratitude and extend my warm welcome to all the attendees for continuing this momentum. My special thanks to all my friends connected from overseas in these odd hours, especially my friends from Vietnam, Mr. Swain and others. With the focus on renewable energy and decarbonization, the utilization of biomass is growing as never before, so as its prices are going very high. As you know, majority of available biomass in India is having high moisture, varying from 25 to 60%. And therefore, a huge opportunity exists to make it more economically viable, provided we are able to select and adopt the right technology for its drying. My sole objective of bringing this webinar to you at this point of time is basically to keep you informed about the possible ways and means to dry the available biomass and improve upon its combustion efficiencies, transportabilities, and reduce air emissions. My today's presentation is going to be in two parts, basically. The first part will provide you enough data on the drying technologies through a case study from one of the installation at Balrampur Chini Mill. The second part of the presentation will connect the dots with respect to the possible upgrades to control the emissions and air pollution, justifying its tagline, that is gaining while greening. So friends, it is going to be a very, very interesting and interactive session as usual. Today, I would like each one of you to stay connected till the end. My backend team will also issue participation certificates to all the participants after the Q&A session. As you know, every learning needs some discipline. So let me just remind you about the ground rules for this webinar. The ground rules are, number one, please maintain a high energy. And I would request everyone to put on your videos so that the energy level is high. Put your phones on the silent mode and be interactive. Use your fingers to communicate through chat box. Put your questions at the end of the session in the chat box only. I would be picking up the questions in the sequence from the chat box. Please honor IP and do not click the pictures of the slides. If you like some portion of the presentation, please put it in the chat box. Our backend team will send you within 24 hours. So thank you so much again for being connected on this platform. And now we will start the presentation on the today's topic, that is biomass dryer and CII awarded technology. But just before that, I have one request to make to all of you. My backend team is going to done a small survey. Actually, what I'm seeing, there are so many faces which are attending this webinar first time on this platform. So survey is going to just, you need to just put yes if you are attending first time the webinar of myself. So survey is started. My backend team is doing it. So whosoever is attending first time, please write yes. Okay, any more left out? Please participate in the survey. Okay, so that about 69% of the attendees are attending this first time. It's a good news for us that many people are taking more interest into these technical subject, which we are trying to discuss and share with you our experience. So let us start today's presentation. Where from? Just a moment, I'm just sharing. Okay. Is the screen visible? Can you just give me a thumbs up if everything is okay and you are seeing this? Thank you. Thank you for the response. So let us start today's topic, which is biomass dryer, with a tagline of gaining while greening. At the end of this webinar, in the last few slides, I would highlight this gaining while greening concept of the biomass drying. As you know, the demand for biomass is growing. And why it is growing? If you see on the screen, there are a couple of regions that in the recent past, the demand of the biomass is growing multifold. And the reasons are that the net zero carbon emission by 2070, the commitment of our nation. And the second one is the mandate of the government of India to replace the fossil fuel by at least 20% in all the power sector. Plus the uses of biomass for different applications, including paper, pelletization, and densification to produce biochar, biocoal, and other products. And then all these reason is growing the demand, and so the prices of the biomass is going up in the recent past. If you look at the prices of the most sought biomass, which is the bagasse, especially it has gone up by more than 50 to 60% in last 1 year. And you know the sources of biomass. If you look at this pictorial view, you find that the forestry crop residue and the agricultural crop residue contribute to more than 50% of the available biomass in India. It is more than 70% in fact. And rest of the biomass. So our focus first should be on these two area of biomass. And if you look at the type of biomass, the wood-based biomass, sugarcane-based biomass, and then you have others, primary and secondary biomass. And if you just go through the list, wood-based biomass, if you have chipper dust, sawdust, and so on. Whereas sugarcane-based, you have bagasse, the pith, and cane trash. And others are coffee husk, groundnut shell, coconut shell, and fiber, rice husk, and others. And similarly, the corn-based, Julia flora, coir-based, mango seeds, all these are different kind of biomass, which has a potential to be used as an energy produce or for some other purpose. And in this biomass, the majority, if you look at the composition of moisture, GCV, and the ash percentage, you find that the moisture in bagasse pith, and the cane trash varies from 48 to 52%. Pith has got a 63%, and then after that, when it comes out, it is 50%, and then cane trash is 18 to 24%, 20%. The ash percentage is low, and GCV as received basis varying from 2,400 to 3,600. And then this pith at 63% moisture has got about 1580 kilocalorie per kg. So this is all cane-based biomass. And this is other biomass, wherein you also note that moisture content is again here 38%, 40 to 53%, excepting the Julia flora, which has got a 10 to 12% moisture. All other biomass has got a moisture varying from 25% to 60%. That means there is a scope, there is a huge scope to reduce this moisture and make this biomass more viable for either combustion or for some other purpose. So our target today in this webinar to find out the different ways and means to remove this moisture and make it more economically viable for the industry. So what are those different methods and how we can dry, and how successfully we can have the minimum cost of drying and better return of investment on the system. So my focus is going to be on this. I hope I'm clear and loud. If yes, please write in the chat box if you are with me so far. Please say yes if you are with me so far, or if you want me to be slow or faster, you just let me know. Okay, thank you. So let us see what are the different ways and means of drying it. You know the type of dryers in the industry which are most common. And there are two types of dryer. One is direct contact, another one is indirect contact. In the direct contact, you have a flash drying and a belt drying, whereas in indirect contact, most of the time people are going for a rotary drum dryer. So these are the type of dryer. So we know the type of biomass, we know the content of moisture present in that, and then we know the type of dryer. Now let us see what else you need for drying. You need the heat source, right? So what are the different heat sources which are available? We'll discuss that. Before that, just see the type of dryer. On the left hand side, you see the flash dryer, which is mostly with a good height to the tune of 20 to 30 meter. Then you have a belt dryer in the center. And then on the right hand side, you have a rotary dryer. All these three type of dryer has got its own disadvantages and advantages depending on the type of material. We need to select and make a right choice. Otherwise, we may not be economically viable if we make a wrong choice for this particular technology. So we will be discussing today how to choose and for what purpose which dryer is suitable. So let us now review the third element of the drying process, which is the heat source. First two element is the biomass itself, second element is your technology, and third element is the heat source, correct? So now, if you see the commonly available heat source in the industry, which is the waste heat, is the boiler flue gases, having a temperature of 120 to 150, 160 degrees centigrade in most of the cases. And this is a waste heat, which otherwise is going to the atmosphere. So there are direct contact boiler flue gas using the boiler flue gas dryer. And most of the time, flash drying is used for this purpose. And you can see from one side, you have a high moisture material. Then from other side, you have a gas at 150 to 200 degree temperature. Then drying, you dry the material and then emission control, and then the exhaust clean air which is going out. So it's a simple direct contact flash drying process which is used for most of the flue gas dryer. The other source is either the waste water, which is hot water from different stream of the plant. This could be another source, or if it is not available, then steam is there, which could be the third source of heating or drying. And if you have these two sources, either a steam or the wastewater stream from the different, either from the boiler stream or from the plant stream, then you can put either a steam coil air preheater or and heat the air by using either the water preheater or the air preheater, and heat the air, ambient air, up to 150 to 200 degree temperature, and use this air for drying of the biomass. So these are the two type of heat sources which are commonly available in the industry. So let me just summarize what we have understood so far. We know that bagasse is the main source of biomass which is available in plenty in India because of many sugar factories all around. And this contribute to more than 30% of the total biomass, 25 to 30%. So our presentation today, I would be explaining you the technology considering bagasse as an example, but this can be applied to other biomass as well. So let us see what are the different objectives which could be there for the industry for drying of biomass. There are four objectives basically. The first objective could be if a cogeneration plant is there, so they may like to save the bagasse by drying the bagasse. They may like to save the fuel, or they may like to extend the cogeneration for a longer time. Especially in sugar plant, if the factory is running for 6 months, then by having the bagasse drying, you can save the bagasse and then extend the cogeneration by another 30-40 days, depending on the capacity of the plant. The other objective could be the bagasse saving. You save the bagasse or save the fuel and sell it in the market for other different purposes and generate revenue through selling of bagasse. And third objective is the improved boiler operations could be another objective, because when you put the dried fuel in the boiler, the steam generation capacity or capability of the boiler goes up by about 8 to 10%, subject to certain conditions, of course. It also leads to the reduction in excess air, reduced gas flow, so thereby reducing the power consumption on the auxiliary equipment of the boiler. Higher furnace temperature by 50 to 60 degree temperature centigrade. Boiler pickup becomes very fast. If your existing boiler right now is taking 2.5 hours for going to the pressure, set pressure, with dried bagasse, you can achieve this within 1 hour. So there is a fast improvement in the pickup of the boiler, and reduced unburnt. Because the combustion efficiencies goes up, the combustion is very good in the furnace. So the unburnt carbon in the bottom ash reduces to more than 50%, by more than 50%. So far, these are the three basic elements which were there in the mind of the user, either the cogeneration extension, bagasse saving, or the improvement in the boiler operation. The fourth dimension, which we added a couple of years back, is the flue gas cleaning, which is not yet explored fully in the industry. But we are now putting up systems wherein the dryer has become a pollution control device as well to a greater extent. So flue gas cleaning is an inherent advantage of this if the system is designed properly and the cyclones are designed properly. So these are the four objectives, and a plant can have combination of these, either of the one objective or two objective, or a combination of these different objectives at different point of time of operation. Let me just give you a little this animated diagram, how the flash dryer is working. So you can just see it and then I'll explain. You take the bagasse through a controlled feeder, and then the flue gases are coming from the boiler, hot flue gases are coming from the boiler, and then it is getting intermixed in the flash tube and going upward with the bagasse. So what happens, maintaining average particle retention time, it carried forward and comes to the top of the flash tube. So by the time it reaches the water evaporation in the bagasse takes place, and the dried bagasse is separated, having a series of cyclones, high efficiency cyclone, which separate the solids from the gas stream, and then the gas goes either through an ID fan if the fan is after the dryer, or it goes to the stack, depending on the configuration of the dryer design. So it looks to be a very simple system, direct mixing with the hot flue gases. The bagasse is carried forward and taken upward to a height of 25 to 30 meters, giving a proper retention time depending on the particle size of the bagasse. And then it is separated using a cyclonic separators. So a standard gas train, if you look at the new boiler, the gas train could be the boiler, dryer, and air pollution control device, and the stack. This could be a new gas train for the new boilers where we conceive the drying operations in the beginning. As far as Enviropol is concerned, we have experience of successfully commissioning around 15 dryers so far on different boiler capacities, starting from 30 ton, 40 ton to 220 tons. And the special features are the regulated feeding. If the feeding is not properly regulated and automated, there has been the incidence of jamming in the previous years, but now it is with the help of regulated feeding, those incidents have gone down to zero. High reduction is moisture. We are targeting the moisture reduction to the tune of 18 to 22%, depending on the inlet flue gas temperature available for the drying. Higher heat transfer rates. The design is made in such a way that the heat transfer coefficient is very, very high when it passes through the flash drying. No air infiltration because the dryer is completely air sealed. So there are no chance of ambient air going inside. This has an advantage. Number one, of waste of heat is reduced. And then at the same time, your fire hazards are reduced if the oxygen is not going inside. Residence time is very, very short. So chances of fire are almost nil. High efficiency cyclones are used. Special cyclonic separators are designed to separate all the bagasse from the gas stream. And the corrosion and erosion resistant material is used. So these are the basically 7 special features of this dryer, which we have been supplying to the industry. And just on the performance parameter, if you look at that, the moisture content, reduction in moisture content from 50% to 40%, your GCV of the bagasse is going up from 2250 to about 2733 kilocalorie per kg. So total gain is about 500 kilocalorie per kg. The moisture reduction in moisture also lead to air ratio. That means the combustion reduction by about 10%. If at 50%, if you are using X amount of air for the combustion, you can reduce it to 0.9x. That is 10% reduction is straightforward. If your 10%, 10 unit moisture reduction is taking place in the bagasse. The steam economy, or if we call it in a normal language in sugar industry, you call it as a raising, steam raising, or the evaporation rate, it goes up from 2.2 to 2.83 kg per kg of steam, depending on the gas temperatures available for the drying. But this is an average figure which we are projecting here. And then the thermal efficiency of the boiler. Most of you must be knowing that every 1% reduction in the moisture increases about 0.4% efficiency of the boiler, thermal efficiency. So when you are reducing 10 units, the efficiency is going up by about 4.5%. So you can look at from the graph that at 50%, if you have an efficiency of boiler at 70, then at 40%, it is going to be about 74.82%. So that means there is a gain in thermal efficiency by over 4.5% when you use the bagasse, dried bagasse from the dryer. And just have a look on this overall performance results of a dryer. This is basically an average of so many dryers which we have successfully installed so far. So these are the average figures of last 15 installations. And you can look at the bagasse moisture reduction to the tune of 20 to 27% we have demonstrated. Bagasse saving to the tune of 6 to 10%. In most of the cases, it varies from 7 to 8% net saving I'm talking about. Excess air reduction. And then effluent gas reduction, the volume of gas goes down. GCV increase in GCV by 18 to 24%. Thermal efficiency of the boiler goes up by 9 to 12%, depending on the moisture content. And then reduction in CO concentration, 80 to 90%. And reduction is particulate matter. Please note this point, the particulate matter reduction is 90 to 95%. We will be discussing this part in the later part of the presentation when we come to the emission control. And also the NOx reduction has been observed to the tune of 20 to 25% because of the better combustion and the specific steam generation going up because of the drying. These are the installations, few of our installations on a 80-ton boiler at BCML, Balrampur. Then 50-ton boiler recently commissioned last 6 months back in Kenya. And then 100-ton boiler again on the same plant in Kenya. Then you have 70 TPH boiler at 42 kg pressure boiler. And then 210-ton boiler, and then 90-ton boiler. So these are different capacities of boiler where we have installed and successfully commissioned the dryer. You can see both the minimum and then identified which Now you can see both the photographs. On the left hand side, you see the bagasse which has got a moisture of about 50%. And you can see the density of the bagasse, the color of the bagasse. And after drying, the color changes and the fiber sizes also the fiber also gets disposed of. I mean, they get fragmented. Color also changes and the bagasse lumps are not seen. So when this dried bagasse goes into the furnace, it burns very fast and the combustion, the heat generation on the boiler is almost non-existent in the operation of the boiler. So I hope I'm clear so far. Would you please help me to just check out if it is clear so far? Please write yes in the chat box if everything is okay and you are with me so far. Okay, thank you so much for the response. Now, I would devote 5 minutes on this case study of Balrampur Chini Mill. You can see on the right hand side, this is a dryer which was installed during the COVID period. It is on a 80-ton high pressure boiler, the 87 ATA boiler. It is a cogeneration boiler on which it was installed. And you can see 80-ton capacity, 87 pressure, 515 degrees C was the superheated temperature. And this you can see feed water temperature from HP heater was 180. And the flue gas temperature for which it was designed, the dryer was designed at 145 degrees C after ESP. This boiler has got a ESP. So dryer has been put after the ESP. Tapping the gases after the boiler ID fan, putting up a booster fan, and then the dryer is installed. So these were the design input and output parameter. Dryer was supposed to provide 39.5% moisture at a outlet temperature of 70 and 135 plus minus 10 millimeter water column was the design pressure drop. At a 140 degree temperature and a gas volume, which was it was designed for 60 meter cube per second at 140 degrees C. So these were the design parameters. And these are the collected data after commissioning. And you can find the design, boiler design, and with dryer, what we have achieved there. The steam generation went up to 87 from 80. But at the time of testing, it was limited to 71 because of the demand. Superheating steam temperature was shown a little increase of 2 degrees. And then you can see the flue gas temperature, which was available 133 as against 140 design. And we reduced the temperature to 72. And moisture reduction was limited to 38% from 48%. That means about 10 units. GCB of fuel went up to 2825 kilocalorie per kg. And fuel temperature to the boiler initially when it was coming, because this plant is across the road. So bagasse is traveling quite a lot before it reaches to the cogeneration plant. So temperature of bagasse was around 30 degrees when it was reaching without dryer, but with the dryer, it was getting around 50 to 65-degree temperature to the boiler. So these were the results. And if we analyze the performance of dryer, we can say that energy gains with dryer and energy gains bagasse moisture, this is 9.63%, that is 20% was the reduction in moisture and 18% increase in the GCV. Boiler thermal efficiency went up by 6%. Steam economy increased by 11 to 12%. Flue gas temperature to the stack came down to 61 degree. Excess air reduction by about 20%. And this CO2 reduction, this is a calculated figure, CO2 reduction to the tune of 33 to 35 tons equivalent CO2 per day. This was resulted because of the increase in steam generation, specific steam generation from the boiler, thereby reducing the absolute emissions and reducing the carbon emissions to the atmosphere. So these were the results. And if you look at the ROI, return on investment, you can find with the 3 rupees per kilowatt hour. This is the figures given per day saving of about 1 lakh rupees per day at that time. But now the savings have gone up because the bagasse prices have gone up from 1750 to about 2500 in that area. And in West UP, it is touching 3500 also in many for a longer duration. So I'll just share with you a video of this particular setup during commissioning.
Hello friends, today we are at one of our project site. Yes, we are at cogeneration plant, one of the most prestigious sugar company of India, Balrampur Chini Mill. And at the back of my side you can see recently commissioned dryer, bagasse dryer. Let's hear more about this project from the horse's mouth. The three key members of project execution team of Enviropol, Mr. Sandeep Premi from project, Mr. Kaushlinder Singh from commissioning side and Mr. Santosh Yadav from construction side.
एनवायरोपोल को ये ऑर्डर लॉकडाउन के शुरुआती दिनों में अवार्ड हुआ था। इतनी मुश्किल कठिनाइयों के दौरान भी हमने इस ऑर्डर को टाइमली कंप्लीट किया है। ये बगास ड्रायर हमने 80 टन बॉयलर हाई प्रेशर बॉयलर के लिए डिज़ाइन किया है। इसमें मॉइस्चर रिडक्शन 18 से 20% का रहता है। एनवायरोपोल इंजीनियर्स ने 80 टन बॉयलर के लिए बगास ड्रायर सप्लाई किया है, जिसकी कमीशनिंग हमने 30 नवंबर 2020 को किया है। और ये ड्रायर बगास ड्रायर हमारे एक्सपेक्टेशन से बहुत ही अच्छा वर्क कर रहा है और ये हमारा 8वां सक्सेसफुल कमीशनिंग है और हम इससे 18 से 20% मॉइस्चर रिडक्शन गेन कर रहे हैं और एमिशन लेवल भी हमें जो हमने अपने पीजी पैरामीटर में दिया है वो हम गेन कर रहे हैं। और आइए हम आपको अपने ड्रायर सिस्टम के बारे में एक्सप्लेन करते हैं। आइए ऊपर चलें।
ये अपना ड्रायर इनलेट आरएवी है जो कि वेट बगास को अपने ड्रायर सिस्टम में फीड करता है। ये ड्रायर सिस्टम का साइक्लोन सेपरेटर है जिसमें फ्लू गैस और बगास को सेपरेट किया जाता है।
So thank you for watching this video. I hope by now we all are clear about the drying process, the technologies which are available, the available biomass and the range of moisture which we want to reduce. Now, despite all this knowledge base which is there in the industry, there are lots of fears which are coming, which comes into the mind of end user. Because this technology, the bagasse drying subject, is a 100-year-old subject. The first time it was tried in 1929 in Australia. But after that, this never went at the required pace, because at that time the bagasse rate of the bagasse and the different applications were not there. So it was a useless commodity. And that is why the technology did not progress as it was supposed to be. Then in 1989, 80s, there were a lot of trials which were done in India also, but they failed because of the boiler designs. That time the available temperature was very high. So people started facing the trouble of fire hazard in the bagasse drying. So again, that 10, 12, 20 years, 10, 15 years, this 6 plants tried the bagasse drying, but they were not successful. So all these failures has got a baggage in the mind of the user. So they have lots of fears still, even after, I think, 30 installations running in India. Even after that, there are many questions. So I've tried to compile all those questions so that those fears can be taken out from the mind. And I'll try to reply one by one why this fear came and how it is a myth at the moment. And there should not be any fear at the moment when the things are progressing well. So let me take out all those questions. The first question is the fire hazard. Whenever you meet some potential customer, or whenever you meet some potential company who is exploring to put up the dryer, the first question in their mind is the fire hazard. And from where this is coming? This is coming from 1980s and 1988's trial, which were done in the industry in India. But that time, we have to differentiate the technology that time which was there and now the technology which is there. That time, the temperature from the boiler were all above 180 degree. And the dryer which were designed was mostly with a very high retention time. And because of that, the fire took place in many installations. And because of that fear, the people are little scared at the moment also. But in the last so many installations which we have done, we have never faced this issue, excepting the ones in the first installation, which was not because of the temperature, that was because of the automation failure, right? So when we are talking of low temperature drying, the low temperature means the temperature of the flue gas is below 150, 160 or 170 degree. At the same time, the retention time of the dryer now, which are designed flash dryer, are very, very low, and completely dryers are sealed. So there is no chance of free oxygen going in. So this fire hazard is no more there in the new designs. So this can be removed from the mind now. The second is the jamming and choking, which used to take place earlier. But now with the well-placed automation of the feeding system and the evacuation system, this choking and jamming issues are not existing anymore on the mill bagasse. Temperature, another question which comes from the end user: what is the optimum temperature to be used for bagasse drying? So on this, my response to them would be that anything above 110, 120 degree is useful till 180. So our temperature band for flash dryer is 110 to 180. 110 will have a longer ROI. 180 will have a very short ROI. So this depends on economical studies. When we do the feasibility study for any plant, all these factors are taken into account to derive to the return on investment. Why I am saying not below 110? Because below 110, the economics is not so good. It takes more than 5 years for the recovery. So it is not advisable. But anything above 110 will give you a good amount of return. Because after all, we are talking of waste heat, that either it is 110 or 120, it is otherwise going waste from to the atmosphere. So you are not gaining anything out of it. So if you can gain something out of it, and it can set off the power consumption in the dryer, you are getting the advantage, right? And the third one, the loss of volatile matters. This question also comes very frequently with some of the technocrats, which they feel that there is a loss of volatile matters whenever we are drying the bagasse. So I would like to clarify on this point to all the attendees that volatile losses takes place above 250-degree temperature. Here we are talking of low temperature drying, so there is no loss of volatile matters. We have tested it at a couple of locations, and this fear is basically, it is out of the myth. This is no more a fear for the industry. Another query which comes, whether to install in suction or the pressure. I mean, before the ID fan or after the ID fan. My response to them is that it can be placed either of the side, either in suction or pressure, depending on the layout configuration which allow in that particular plant. But there are some advantages of suction, there are some disadvantages of suction, similarly for the pressure. So we need to study this carefully depending on the layout and other factors on the case-to-case basis. But both options are possible. Then operation and maintenance, another question. Some people feel that it is highly, it needs a good amount of maintenance cost. So let me tell you, with the kind of designs we are talking now, the maintenance cost is not very high. It is very, very low. It is not more than 1% or 2%, maximum 2% of the total capex of the dryer. Only 2-3 things we need to take care other than the booster fan and normal maintenance. This has got a sealing in the rotary airlock feeders, which are used for the input and the output of the bagasse. So that sealing needs to be changed. That is the only routine maintenance. Otherwise, there are maintenance with respect to the conveying system and with respect to the your booster fan. So there is no major maintenance as far as this maintenance is concerned. Then adaptability of dried bagasse. This is another question which is very, very, the important question. Some questions or some queries came from a couple of potential customers that our boiler is a low pressure boiler and we may not be able to use this dried bagasse in the boiler. So on this, I would like to emphasize upon that anything, either it is a low pressure boiler or high pressure boiler, it doesn't make any difference for the uses. In fact, the low pressure boiler has got a better flue gas temperature and you can dry the bagasse better. But depending on your combustion chamber situation, the soot blower positioning and the connection of the overfire nozzles, we can take this call at what moisture we need to fire bagasse in this boiler. 40%, up to 40%, there is at all no problem in almost all the boilers. And in most of the boilers, up to 38-37%, there is no problem. But when you come down to below 35%, then there are some question marks and we need to decide the strategical locations of soot blowers and the overfire nozzles may require some strengthening. So these are the only two things. Otherwise, there is no problem as far as the combustion of low moisture bagasse is concerned. Return on investment depends on the rate of the bagasse. In current scenario, if I take the rate as 2,500 rupees per kg on an average whereas in North India it is much more, but at 2,500, the dryer is having a return on investment to the tune of about 250 to 280 working days. So this is a normal, the average return on investment for the plants. The operation maintenance we have already discussed. Then another point which is now picking up the importance is the decarbonization and carbon credit and energy saving certificates. Probably you all know that the sugar industry has come under PAT. And recently the government of India in May 2023 has already declared that whatever amount of a specific steam generation you increase, you can trade and get the energy saving certificates and trade it. So this advantage is there with the dryer. When you use the dry bagasse, you are reducing the absolute emissions, you are increasing the specific steam generation from the boiler, and thereby this energy saving certificates are applicable. On the other hand, the carbon credit trading is also applicable on this particular setup, because you will be equivalent amount of coal you are going to get the set of the Indonesian coal, and because of that the carbon credit is also applicable. So you can claim both e-certificates and the carbon credit if you put up a dryer for reducing moisture and increasing the efficiency of the boiler. And the last question is on the emissions. And this is a very valid question in my opinion, because most of the people think that it has got a cyclonic separator at the end before the gases are let out. So how you can reduce the moisture content, because normally everyone thinks that cyclone cannot have an efficiency of more than 80%. So this is a myth again, and I would like to clarify why the outlet emissions are controlled to the desired limit and how it is done. Before I explain that, just see this particular graph and understand what it is. This is an analysis of bagasse particle size versus the bagasse ash particle size. If you see, the orange color is fly ash and this dark green color is the bagasse, and particle size is on the y-axis. And if you look at it, you find that bagasse particle size starts from 75 micron and goes up to 4000 microns, whereas the ash of the bagasse almost finishes at 7500 microns. That means there is a big gap in the particulate sizing, and thereby you cannot compare a cyclone running on ash and with a cyclone running on bagasse, or the dense mixed of bagasse and flue gas. So this is the major difference. Because of that, you are able, if the design of cyclone is properly done, this cyclone and the ash cyclone are not identical. They are different in construction, they are different in designs. And if they are properly done, you can achieve an efficiency of more than 99.99%. We have tested it at various locations. The bagasse sizing is almost same as 85 to 90 pi, and then you get a good efficiency on the cyclonic separator. The loss of bagasse flow has been to the tune of less than 0.003%, which is almost negligible. It is not visible even in the thimbles. So this is what it is. But there is another question which is coming and picking up now in the industry, that okay, the fly ash will not go, but what about the fugitive emissions sometime if it goes because of the malfunctioning of the dryer? That is the point which needs to be taken care of. So I will be explaining you in the next slide how we have devised a mechanism not to allow any fugitive emissions to go into the atmosphere, even in the condition of malfunctioning of the dryer. So that part has basically landed us into another range of dryer, which is called a hybrid dryer. And this hybrid dryer is basically an integration which will give you the bagasse drying and the flue gas cleaning in the same circuit or in the same box. And the hybrid dryer are also of two types. One hybrid basically replaces the dry ESP completely, and another hybrid is a mild hybrid where you have the ESP already in the plant, and then you have a dryer, and then have a mild hybrid with a low pressure drop scrubbing system. So I am going to explain you both the hybrid, and let us first see the full hybrid, where you are conceiving for a new boiler. There is no ESP, you have air preheater. After air preheater, you have a dryer, and after that, you attached with a wet ESP. Because the dry ESP cannot work after the dryer because of the high moisture in the flue gases. So we need to either have a wet scrubber or a wet ESP. And wet ESP is the most advanced technology as on date in the across globe for reduction in particulate matter. down to below 5 milligram, 1 milligram, or 2 milligram. It depends on the efficiencies requirement. But for this sugar sector or for the biomass sector, we are targeting up to 10 milligram outlet emissions and a moisture reduction of 38 to 40% from 50% coming from the mill. So this is the hybrided model, which is our patented technology. And we have a Swedish collaboration for making this wet ESP as an integral part of the dryer. And this system has been successfully used at Dorala Sugar Works, the first installation of the world. And this is on a 90 TPH new boiler. And you can see this is a very compact installation where the APH outlet and chimney has got a distance of about 12 to 12.5 meter only. There is no ESP. After the APH, the gases are directly going to the dryer. And after the dryer, it is connected with a wet ESP, this red color, and you clean the gas down to below 30 milligram. I'll show you one video of this installation. So this installation was designed for a gas flow rate of 220,000 meter cube per hour at 140 degrees C. Outlet emission was planned 50 milligram, whereas we are getting less than 50 now. Bagasse moisture dropped by 22%, net bagasse saving 7%, and this was commissioned in year 2019. You can see the video. And this particular combination has got a potential to replace the maintenance-prone dry ESPs on the boiler or biomass firing. And if it is conceived in the beginning, at the time of boiler installation, you can have a very smaller footprint. The boiler foot length reduces by almost 15 meter directly for a 100-ton boiler I am talking about. So reduced footprint and better emissions, no maintenance linked to the dry ESP, which is there normally in the plants. And you have a bagasse saving to the tune of 7% and emissions of less than 30 milligram. And the boiler which are being retrofitted and dry ESP is already existing. So when the dry ESP is already there, we are only focusing on the fugitive emissions if it goes sometime during the malfunctioning of dryer. Malfunctioning here, I mean, sometimes the mill stops or sometimes the bagasse received to the dryer is suddenly goes down. And if it goes down to a very low level and the flue gas quantity is same, then there is a chance of some particles going out of the system because of the very lean mixture. Or sometimes the boiler generation goes up. That time the volume of flue gases goes up. That can take away some particles. So to control those unforeseen moments during the malfunctioning of dryer, though the dryer is fitted completely with automation, but still you cannot rule out anything. We need to take precautions, as well as from the pollution control point of view. Also, you need to have something to contain the fugitive emissions of emergency nature, right? So in that case, we have two models of mild hybrid. The first model, we have a inline wet scrubber, which is directly connected in the outlet ducting of the wet dryer. So this is inline, and we can completely remove the fugitive emissions from this particular design. And another one is connected with a low pressure drop scrubber. This is also a hybrid model, the variant 3, where the pressure drop about 50 mm water column is given and the fugitive emissions can be removed. This combination can also remove the other emissions coming from the boiler, because if you have a design, properly designed this scrubber. So all three variants are capable of reducing the emissions from the boiler. So let us now summarize what we have learned in last 1 hour. And let me just remind you on the major takeaway from the hybrid system. As I explained, the flue gas cleaning and bagasse drying, it takes in one shot in this hybrid model. In other words, it is now converted into a revenue generating APC model, because dryer is reducing 90% of the emissions already. Whatever is left out is only 10% fine particulate matter with a reduced volume of the flue gases, because dryer reduces the temperature to about 70. That means the volume of the flue gases is already down by more than 30%, and the particulate matter are down by more than 90%. So whatever is left out is a very small quantity of dust, but very fine. So you need a proper system to remove those fine particles, and dry wet ESP fits very well in this configuration. So the complete system combined together is a revenue generating with respect to the emission control and bagasse saving by almost 7%. Footprint is very small. It has a capability to reduce emissions by less than 10 milligram. Gas cleaning efficiency is more than 99.5% combined together, wet ESP and dryer. It also reduces the greenhouse gases because wet ESP is known to remove aerosols. So whatever greenhouse gases gets condensed within the wet ESP, they are separated in the form of mist, and the mist is collected on the electrodes of the wet ESP. Power consumption is quite low as compared to the dry ESP, and substantial control on aerosols. When I talk of aerosols, it could be presence of mild sulfur, which converts into H2SO4 mist, or other toxic gases. Those can be condensed in the wet ESP. So this is the model, which is a futuristic model for revenue generating APC. We have been in talk with the Pollution Control Board as well on this, and they have recognized, and we have been awarded last year by CII as a most innovative product and energy saving product of 2021. So if you summarize the benefits, there are some qualitative benefits which I have already explained. But at the same time, if you look at the quantitative benefits, you can look the emission control, and then milled bagasse moisture reduction, net bagasse saving 6.5. This was achieved. Productivity enhancement by 9%. Carbon emission reduction 30 tons equivalent CO2 per day. And then revenue generated from this 90-ton boiler was about 160 lakhs per season during 2019, I'm talking about. But if you have the rate, that time the rates were about 1750 rupees per ton of bagasse. So as on date, this for a 90-ton boiler, this revenue would be the range of 320 to 350 lakhs per season. So this is an overview, and we call this model, our tagline is gaining while greening. You generate revenue while taking care of your environment and meeting the pollution control norms. Moisture reduction, high return on investment, and emissions. You can have always less than 50, can be designed for less than 10 or even lower than this. This was the award which was given by CII for most innovative and energy saving product of 2021 on this. There are a couple of more. This particular technology is patented by Government of India, and we have been awarded by various different forums on this technology. Now, before we end the session, let us have an overall look for a 20 megawatt cogeneration based power plant, bagasse based power plant in sugar industry. What this dryer hybrid model can provide for a 20 megawatt cogeneration plant. If you calculate a 20 megawatt plant can generate extra energy of 1.2 to 1.5 megawatt hour because of the drying. Particulate emissions can be down to 10 to 50 milligram per mm cube depending on the requirement. Other pollutants are also reduced because of wet ESP in picture. SO2 is normally not there. Mercury is normally not there in the sugar industry, but it can be there for other type of biomasses like Julia flora and mustard husk and all. So that is the reason. And if these elements are present, these can also be scrubbed in the wet ESP. Wet ESP is known for removal of SO3 mist and H2SO4 and heavy metals like this mercury. Amino acid, it is countered by alkaline water. And if you look at on other quantitative achievements, the green power, additional green power is 900 to 1200. N2O reduction and the overall emission reduction to the tune of 1000 to 1350 equivalent of CO2 per month. And if I convert it on a national level, you can find, considering the 500 plus sugar mills with a 8,000 megawatt of cogeneration, we have a potential to generate green energy additional of 2100 gigawatt with plus 2 million tons of CO2 reduction in the greenhouse gases on yearly basis, considering 170 days of sugarcane crushing per season. So this is the potential which this technology provide to the industry. And once it is applied, then slowly and gradually we start seeing its benefit in the different plants. Thank you very much for your patience hearing. And if you have any question, please put it in the chat box. We can take it up one by one. But before that, I think my backend team will issue the participation certificates to all the attendees. In the meantime, you can put up your questions and then we take it up one by one. Thank you so much for your patience hearing. Yes. So let me take up the questions. There are a couple of questions which I can see in the chat box. The first question is, how do you manage the temperature of 61 degree to stack as the acid dew point is reached? Normally with bagasse, this question is from Mr. Sudarshan. Normally in bagasse, this SO2 is not there in Indian context I am talking about. So we can easily discharge the temperature up to 63, 64. There is no problem at all. The 61 which you are referring is after wet ESP, wherein the gas is completely saturated and all the acid fumes or acid mist are already separated. So it is quite safe for the stack and succeeding part of the wet ESP. Another question is from Mr. Satish Bansal. He's talking about the palm fiber and palm bunches. Yes, we have explored this possibility, but in the flash drying, for using the flash dryer as a mechanism for doing it, the palm bunches and the fibers has to be properly prepared. Otherwise, this may not be possible to be used for this flash drying. If they prepare it nicely, they will have to put up some hammer mills and then reduce the sizing and separate the fibers which are normally entangled in the palm industry. So this flash drying is a difficult option for that unless it is properly prepared. Next question is from Niharika Sharma. The presentation is really very informative. Can you please share this presentation for us to read after the reading? Yeah, definitely, Niharika ji, we will, my backend team will just reach out to you and provide you the extract. Mr. Bhojraj, what is the optimum velocity to be considered? If I'm not wrong, Bhojraj ji, if I understood correctly, you're asking of velocities of the flue gases, right? So there is a empirical relation between a velocity of the flue gases versus the average particle size of the bagasse. So it varies from the preparatory index of the cane and the bagasse particle sizing. But as an as a thumb rule, you can say it goes from 18 meter per second to above 35 meter per second. This is in this range we can design a dryer. This location of 20 cogen plant, Mr. Bhojraj, this 20 megawatt was taken as an example. It is not existing plant, but wherever we have put up is either more than 20 megawatt or less than 20 megawatt. We can definitely look into any exactly 20 megawatt power plant if it is there. But calculations are made considering 20 megawatt as a just to showcase the total gains on a sample case basis. So next is thank you, Mr. Guru Prasad, for giving us the best wishes to promote this technology. Yes, Mr. Piyush Jain, it can be helpful for your cotton crop residue and Julia flora because the sizing is quite optimum for this material to be used for a flash drying. Next is Mr. Arvind Rai. We are using bamboo chips with coal in our CFBC boiler, 20% ever. Can your system work for this? Mr. Arvind, you can let us know the bamboo chip sizes. We have tested this type of dryer up to 10, 15, 20 millimeter size. But if it is more than that, we may have to properly make it up for using into the flash dryer. Any calculation, Mr. Rajiv, any calculation for calculating flue gas quantity for drying the bagasse? Yes, it is a simple heat and mass balance calculations which are run for achieving to the quantity and the temperature of the gas. So we can discuss on this separately. Thank you, Mr. Guru Prasad. Most of the fears and queries are well answered in the systematic way. Next, Mr. Vikas, is there any provision to remove SO2 gas completely from incineration boiler flue gas stream? Yes, Mr. Vikas, you can definitely, we can discuss. It's entirely a different subject. This is called the flue gas desulfurization. We have different kind of systems to achieve this. We have a wet system, we have a dry system, we have a semi-dry system. So we can discuss on this SO2 removal completely. When I say completely means not more than 99.5%. 30 to 40 mm size, we may have to test it. We have tested up to 20 mm, so we may have to test it for 30 to 40 mm. We can discuss, Mr. Arvind. You can send us you can reach out to us with your proper PSD, particle size distribution. Let us talk within our team and see if we can make it up to 30 and 40 mm. Next is Mr. Rajiv Mishra. At Mezapur site, we have 75 TPH boiler, slow fired boiler. The reason and off-season boiler operated on 100% bagasse, but ESP inlet temperature is 135 to 140 degree. Can you? Yes, on this boiler, I think in past we have studied this particular boiler you are referring to, and putting up a dryer is very much possible on this. Thank you so much. Thank you, friends. Thank you for joining me once again after a gap of 3 months, and look forward to see you in our next webinar. Our team will keep updating you. Thank you so much. Bye-bye. Thank you.
With over 370 installations across 20 countries, Enviropol have been able to clean the air by over 12 million tons of solid particulates and 250 million tons of gaseous pollutants. This has made a positive impact in better agricultural growth, health and safety of human beings in the vicinity of the factories, besides creating employment and byproduct. Enviropol has been pioneer worldwide in supplying various new technology in the field of air pollution control. It is rated number 1 amongst few Indian companies in the entire spectrum of air pollution control business.
Hello friends, with ever increasing demand of biomass for different applications, its prices have gone up exponentially high in the recent past. This market scenario has put back the focus on reducing its moisture to improve upon the combustion efficiencies and its transportability. This webinar is a must-watch for all the decision makers, managers and operators who are operating biomass-fired boilers and wants to increase their boiler efficiency and save on fuel cost.